Hey, it's W5HRO. Well, I got this PAL VFO modified to make this Courier 23 work on 10 meters. You can see right there I've got 39.635. That's what I need if I put it on that one crystal slot to make it output on 2900 even, 29.000 megahertz. So what I've done is I've actually got to where when I widen the VFO all the way to the low end, at the bottom end of it, it's going to put the radio at 28.795, 28.795. And when I go all the way the other way, it's going to put it at 29.300. And I think that's close enough for what I need, because that 29.300 is the very top end of the phone portion. The AM window has always been considered from 2900 to 29.2. And I think a lot of people run sideband above that. I very seldom used to ever hear stations up that high anyway. They were always down the 2800 or 28 megacycle portion above the CW portion of the band anyway. But you can run AM up to 29.300. It's just a kind of a gentleman's agreement thing, which there's no activity up there and nobody's going to care. So anyway, that's how I have it set up. So when I'm going to be outputting on 28.795, the VFO is going to be at 39.430. And then when I'm at 29.300, the VFO is going to be outputting 39.935. That's how I've got it set. From one end to the other, that's what I get. I get those two frequencies. So it's going to work out perfect. Anyway, this thing's really stable. Now I did change out that crystal, and by the way, I think in my last video I said it was a 34.400 crystal. I was wrong. It's a 34.300 crystal I got from Mauser. It's like $1 something. They were like $1 something a piece, so they were really cheap. And I did order these transistors. I did replace that one FET that's the part of the crystal oscillator. I changed out this one, which is the mixer or multiplier. And then I changed out these two 3904s. And you can see where I did replace that 2200 mic filter cap with a 4750 volter. And the other thing I did was I put an RCA jack on the back and I grounded this board. I took out the black, the black fabric type insulators to where the board would be grounded, the chassis grounded this thing. What PAL did on these things years back is a lot of the CBs that they used, that these things used to modify, they had this coax coming out of the back on the majority, I think on all of them. And the shield of the coax was floating. It was connected to the ground of this board, but it wasn't connected to the ground of the other master oscillator and the chassis. And they did that because a lot of the old CBs, this one wasn't that way, but a lot of the other CBs, like the newer solid state ones and some of the old tube ones, the crystals, the one side of the crystal was not grounded to chassis ground. It was floating. It was connected to the circuit board's DC ground, and that DC ground in a lot of the radios were isolated from ground. I mean, they were like, they weren't connected straight to chassis ground. They were a DC ground that weren't, you could take an ohm meter and there was no continuity, or they would use some big resistor between the grounds of the board and the chassis, or they'd put a cap. That's what they did on these. They actually put a cap trying to stabilize it, and they put like a .22 mic in this one. But that right now, the cap is just shorted across because I've got this thing shorted right at chassis ground. And this Courier, the crystal, like I said, the one side of the socket is connected right at chassis ground. I ohmed it out from the crystal socket on that pin, all of them, to the chassis, and it's a dead short. It's like 0.1, 0.2 ohms or something. So it's not really going to matter. Plus, if you look at this schematic, it shows them, see, they're connected to chassis ground. There's no DC ground, but they went ahead and they made all these PAL VFOs like this to where that way if you had a radio that required a DC floating ground connection, you would just solder this into the shield that went inside the radio to that DC ground. That's why they did it that way. But in this case, with this radio, it's not going to matter. So I just shorted that board to ground and put the RCA jack on the back, and that'll make it a lot more stable anyway. So anyway, that's what they did. And by the way, this is the schematic for the Courier 23, the plus model, which I've got old one of these out in the garage, and I got those transistors from the back off of. I'll go back over that in a minute. I think I mentioned that in my last video, what had happened. But The old ECI Courier schematic, I've looked at it, and this radio was right before they came out with this one. This one version here has the majority, almost all of the mods, except for there's a couple of components here and there that aren't in this one that weren't on the original ECI, but the majority of the components are. And of course the crystals were also grounded on the ECI schematic on the one side. So what I'm gonna do is I'm gonna take the piece of coax I took off this VFO, and I think what I'll do is I'm gonna drill this one hole out here bigger and put an RCA jack. Then I can connect this, coax cable, run it, tuck it on the bottom, get as close to the chassis as possible. Then I'll stick it up through here, this hole that's right here, and see what I can do. I'll just, oh God, where'd I go? I can just run it. See, it's gonna be right in here. It'll come up. I think this piece of coax is just long enough. What I'll probably do is the terminal strip right there, one prong's grounded, the other one's just floating. That's where they had that pot for that audio modulation adjustment to adjust the clipper, which I'm going to redo that circuit anyway. I can probably just put it here for like a strain relief, then running like another short piece from there over to the crystal. I'll solder it on the pin on the wafer switch. I'm not going to go to the crystal socket. So that's how I'll probably do it. I'll just have that piece of coax going from there. I'll get it tucked real close to the chassis. I'll get underneath all these wires and see it'll just solder to there. Plus, I may need, what I've also done is I removed that bad pot and I just put a 100 ohm resistor to ground on the emitter to ground on that transistor, which is it's a emitter follower transistor circuit, right? So basically it's a buffer so you can load the output down. It's not gonna hurt it. So anyway, I can put like a capacitive divider there on that terminal strip. That's why it'd be a good idea to solder the one in the coax there first before it goes over to the other. And I can use like a little shorter piece of coax from there on over, but I could put like an attenuator there if I need a capacitive divider or resistor divider going to ground that kind of get to reduce the peak to peak voltage down if I need to. I may not need to. This thing may be fine, but that's kind of what I'm looking at here, and it should work nicely. I probably won't get to this again until next week, and it's Sunday here. I have to go back to work tomorrow. So I had this all set up here. What I do is the XYL works from home during the week, Monday through Friday. And, she worked in San Jose where we moved from. And when the pandemic hit, she was able to start working from home, and that's become permanent. So she sits around the house all day and she gets kind of bored, and she, because she's working from home, she misses getting dressed up, going to the office. So she found a part-time job on the weekends. So she's gone on Saturdays and Sundays here. She just got home a little bit ago. Her and my daughter went to Elk Grove to go to her sister's and her cousin's house. So she'll be back later tonight. So what I do is I set up my workstation here on the island out here in the kitchen is what I do. I got a nice cover for it. We have an outlet right here, where she plugs in the rice cooker and all that good stuff. So I use that to power everything. And I just leave it in here until like Sunday night before I go to bed. Then I take everything off. Then next Friday night or next Saturday morning, I'll get out here and I'll cover it up again. I'll bring this stuff back out here. So I'm just doing this on the weekends because my workstation's out in the garage, and today it's like 97 degrees, and I'm not going to go out there and sweat. And then when I was doing my other stuff this last winter, it was too cold. So I'm like, screw it. I'll just do it here. And this is a nice setup to work on my stuff. This is a really heavy thing that's padding this thing, so I can do all my work here from the kitchen island here. It's nice. So I'm eventually going to set up my shop out in the garage, and I'll get some kind of an environmental control unit out there so I can compensate. But until I do that, this is where I'm working on my stuff. And the XYL doesn't seem to have a problem with it. So as long as I get it out of here tonight before I go to bed, she's happy, because she gets up in the morning, it's all gone. So anyway, that's kind of how I've been doing this. And what was I going to say also? Oh yeah, I'm going to mention this again. In my last video, I think I did mention this, didn't I? And when I said the video before, I said these transistors were getting really hot. What I found out was the one here was bad. So I actually pulled the old ones off. I have all the old parts here, by the way. I don't throw anything away until I'm completely finished, because sometimes there's some stuff that's still good that I keep. Yeah, these are the ones that I pulled off. These were bad. and the other one measured kind of flaky, but one of them was shorted, and that's why it wasn't shorted. There was one of the gates in there was not the gates, but I think the base to emitter was shorted on one of them or something was wrong. Maybe it was because these are PNPs, these are germanium PNPs, so they're slightly different. But what they were is the old switching regulator transistors. Now I did order some new ones. I found these things these are pretty much non-existent now. I found 3 on eBay, the exact same part number. They're Bendix. So I did find a set of them that have never been used. They're new old stock. So I just thought I'd better get those just to have a backup spare, because the ones I have on here, I pulled off that old Courier 23 Plus out in the garage, and they both still work. So I'm just going to leave them on there and not worry about it. But if they ever go bad, I've got a set of replacements, and I got an extra one too, in case one of these turned out to be bad or something. So anyway, but I went through and you can see how I changed all these capacitors. I put a 0.1 here from the mic jack. I replaced this one over here. I replaced the one over here. I did replace that one across the output of that secondary, that transformer. I found the exact same one, same voltage. So I did replace all those, and I replaced the 2 electrolytics, and I put that other one that was on top, where it was sticking through that hole, this one here. I actually, I put, what was this? This was the, 40 mic, 350 volts. I put a 47 mic, was it 500 volt or 450 volt? It's a bigger one, it's right there. So I put that one there on the bottom side, it was easier. So anyway, I replaced all those old paper caps and the electrolytics, and of course, the one there, the big filter can there, that one's brand new. And I've got a 6CW5 in there now, and the power on this thing came up over 5 watts. I think what happened, what I used to have, and I remember when I told you here in my last video that when you run these things off DC, those 2 transistors make up the vibrators. I don't mean multi-vibrator. The vibrator circuit, they go zzz when you power them up. The Courier that I had years and years ago, I did not use the supply that was in there. I mean, I didn't power it from AC. What I did was, and I had this same G model PAL VFO, not this one, but I had another one. And I don't know what crystal I used. I'm sure it had to have been a 34 point something crystal. It had to have been. Or maybe it was, because you've got some play, because you can adjust the coil right there. See that slot, that metal, that screwdriver slot down there? That's that's part of the master oscillator. So you can turn that. So I don't know if I had like a 3300 point something crystal or 30, I don't know what I had, but it was like it was back in the 70s. That's been too many decades ago to remember exactly what I used. But I basically did the same thing. I changed that crystal, tuned the thing up, and I made this my old Courier 23. I had the same radio, not this one just like it. It wasn't mint like this one is practically. This one's beautiful. And then I had the same PAL G model VFO that I modified. But what I did was I had a Vista 20 amp power supplies. Remember the Vista supplies? I think I got it from a CB or something. It was a Vista, it was a new one. It was a Vista 20 amp supply. And I had the one I had powered up, and I ran it on DC. So the thing was always like zzz, when the vibrator was running. The thing is though, the output power was a few more watts higher. It actually beefs the output up, and so I'm only getting like I think I was getting like 6 maybe watts, 6 to 7 watts out of this thing, maybe almost 8. So it's a lot lower, because I used to get like almost right at 10 watts. It was like 9 3/4 watts out of the one I had years ago in Tulsa that I had the 6CW5 tube in. But that's with the Vista 20 amp power supply powering up this radio. So I guess, but when you do that, you will get more power out of these things. It doesn't matter, because I've got the matching 100 watt linear that's going to hook after this thing. And that thing's going to work great. So I should get the full 100 watts with the drive beefed up a little bit into it, like I'm going to do here with that 6CW5 tube. It should work great. And the other thing is the clipper circuit. Let me see if I want to turn this thing upside down and show you. What they did was that pot that I removed, see these 2 diodes right here? there's a clipper circuit in these things. And if you look at it, like I said, this schematic is almost identical to this radio. This is for the plus. The ECI didn't have the extra parts or nor the clipper circuit. It never had it. And I've looked at this one. Now this radio that I have, it does not have this 47K to ground. I'm sorry, 4.7 meg to ground. It's a meg, 4.7 meg. I think that's part of the squelching connection, but they didn't, this radio does not have that resistor. I've looked. It's got everything else except one other part it doesn't have. And what I'm going to do is, if you can look at this, see what they did was, they had these two diodes back to back here, and the 330Ks going to ground. You'd adjust that pot that I removed out of here, and it would adjust the DC voltage on these two diodes to where it would start clipping, you know, the top and the bottom of the AC modulated waveform. So what I'm going to do is I'm just going to bypass this circuit. See, and they used like a 1 meg circuit to isolate this thing, because I'm sure when you adjusted that pot too far the wrong way, it started kind of affecting this. And they put like a, see this cap here? They put that 20 mic, it's actually part of that big can filter. Well, that's still hooked up, and they put it right there close to the tube where this is to keep the thing from, you know, it was probably oscillating. The voltage was probably moving around when you adjust this pot, which is why they did that. So this is all gonna be disconnected, and what I'm gonna do is, I'm just gonna take this cap here, and I'm just gonna take this end of it and put it right over to here. And the other thing I can do is, now right now, I've got the 0.1 microfarad cap right there. The 100 mic cap, the 100 picofarad cap can stay there. That's just for RF bypassing. But they've got, this has got the 47K and the 2.2 meg to ground. I could jump her across this one. And the 2.2 meg is more than big enough for my deep voice for the grid of this tube. But if I do that, if I jump her across this one and just leave that 2.2 meg there, I might not need an amplified D104 on this thing, because that's going to really, you know, that's going right to the grid of that tube. I'm just going to have to play with it. The thing is, they've got the cathode of this tube tied right to ground. It might help to put a resistor to ground with a bypass cap there. I'll have to play around with it, but I'm gonna eliminate this section of the circuit. I'm just gonna, you know, see how they got this? What they did was they went over from here to here. This whole circuit here, from like here, is going to be all disconnected. The whole part of it's going to be gone. It's just, I'm just going to leave it in there. I'm just going to bypass it. I'll remove this cap into this cap from here, and I'll just bring this one right over to here. So the output of this stage will go right through that cap over to here into this. Now, I'm not sure why they put a 0.01 to ground. That'll attenuate some of the highs. That might be okay though. It might be to stabilize it when because you got to play around, because you got to be careful, because if you remove too many parts and change too many things, it might affect the receive and the squelch circuit on this. So you got to be careful. It's not like modifying just a straight transmitter. This is a transceiver, and these audio tubes are also for the receive audio, so you have to be careful what you remove. This may need to be there for the receive audio. I don't know. I might be able to lift this from ground or just disconnect it, one leg of it, and see what happens. But I think if I just modify this like I'm going to, this is really beef this thing up. It may overdrive these sections. That's what I'm going to have to figure out. They may have put these things here to keep from overdriving this other stuff. That's what I'm going to have to play with to find out. It may be fine. It may be they thought, well, a lot of people were putting like amplified mics like a D104 on these, and maybe a lot of people were running them up too high, and it was really overdriving these things. That's what I'm going to have to figure out. But if I do this, it's possible that you might not need an amplified D104 on this thing. Because the one I had years ago, all this stuff was left in there, and I just would adjust that pot for maximum audio where it wasn't clipping it. But everything else was still in there, so that may have been why I needed the mic to drive it, like this resistor here and everything. But like I said, in this radio, this 4.7 meg is not there. It doesn't exist, so I'm not sure why they added that. And on the ECI schematic, it's actually in there, but they have two X's right here. I'm not sure why. Now, the other thing that I'm thinking of doing, here's the thing. The ECI Courier 23s had a relay with more poles and more, the more poles and more connections, right? What they were doing on the ECIs, when you transmit, it would completely disconnect the receiver, the receive section of this circuit away. It would disconnect everything. Because the way this is, so when you transmit, when you're transmitting, you're modulating up through this stuff. Look, even though it's going to this tube, it's going to get through this coupling cap, through this resistor, through this pot to ground. And what they did was, what it looked like they did was on the ECIs, since the relay had more poles, it would actually disconnect. It would actually disconnect this here, I think, and it would also disconnect. There was something else that it just, I think it disconnect. What it did was it would disconnect this 4.7 meg resistor. Now, when Fannin took over and they came out with this one and they redid these schematics and the circuits a little bit, they removed those extra poles on the relay. The relay in this one only works for transmit, like for TR switching and stuff. And I think it does mute the receiver, but it doesn't physically disconnect this other circuitry that's used for receive audio. So what I may do in the end, it may not hurt anything, and that's kind of probably also why people had to run an amplified mic into these things, because it was dividing off into all this other stuff. On the ECIs, you didn't have that problem. So if you were to modify the input to this thing like I'm going to do on this one, the speech amp, you probably didn't need an amplified mic because all that receiver stuff wasn't hooked up. So what I might do is I might get a small little relay in here somewhere and just mount it and do the same thing the ECIs did, where I can actually disconnect that stuff. That's another option. I won't do that right away, but before it's over, I may actually do that to disconnect that receive audio circuit. Because I think that's what I know that's what they did, because I've looked at the ECI schematic. I don't think I have it here, or do I? Maybe I do have it here with me. I thought it was still in the downstairs shack. Oh, here it is, I do have it. And see the extra relay connections here? This relay doesn't have it. It doesn't have it. But see how there's the 4.7 meg. See how they have the X's? What that meant was when you're transmitting, it would actually disconnect that resistor is what it would do. And see how they had this over here? Where was it? Where's the, the other audio? There's the audio section. See what they would do? See the X's here and stuff? They were doing, what were they doing? They were disconnecting some of this other stuff. See there's X's. See there's X's here. They were disconnecting this resistor that's used the receiver audio passes through and goes to here. That's what they were doing. See, the X's mean that got disconnected during transmit via the extra relay contacts. Like I said, this relay and this radio doesn't have it. And I'm not sure all the wires going to that relay are necessary. They probably just use those for jumper terminals, like to connect wires from here over to here. Some of them, there's a lot of them I'm sure are no connects, because this relay doesn't have that many poles and that many connections, the one that's in here. So that was the big change that they made. The ECIs did it right by they disconnected the receiver audio circuitry so it didn't affect it when you were modulating through the circuit. This Fannin Courier does. So that it may be worth doing that. So I will look into that. So I just kind of wanted to point that out if anybody's ever worked on these things before. And I tell you what else, what I found out is that some of these old radios, like these old CBs especially, some of the parts for these things are almost non-existent. Like these transistors I was telling you about, that I found those new old stock. I mean, try to find more of those. Good luck. I mean, unless you find a junk radio like I already had to pull the ones out of, you're kind of screwed. So a lot of this stuff, it's getting to the point where I've noticed, 10 years ago it wasn't as bad. But here lately, a lot of these older parts, like the transistors, you have any idea? I usually don't spend that much money on this stuff. See that one transistor right there for the multiplier, the mixer multiplier? That transistor was $26. I'm not kidding. That's how much that thing was, because they haven't made those things in so many years. and I found a supplier that he can get me anything that I need. I have to wait a few weeks because it's like they have to back order it, but they can get them. And some of this stuff is getting to be really, really expensive. Now, tubes they made a billion of, but TO3 packages, forget it. Some of those things are almost completely gone now. So some of the parts for these old radios, in another few years, you're not going to be able to get any of them, and it's going to be over. So if you want to modify one of these things for 10 meters, I suggest you get one now and get cracking, because you're going to get to the point to where this is a dying man's hobby, right? And it's just, of course, those parts were used on a lot of commercially made stuff too, all kinds of consumer electronics and so forth. But still, some of this stuff's getting to the point to where one of these days you're not going to be able to fix it. And it dawned on me, I have that Max stereo downstairs, the one that was made in 1968. I found that the thing's like in mint condition. It's a solid state, but it's got a tube tuner in it. It's got a hybrid. It's a hybrid stereo 40 watt per channel stereo receiver, and I think the first one or two stages on for the receive FM, they use like Nuvistors, or they use FETs. I gotta go back and I gotta look at it. And then after that, it was tubes. The rest of it was tubes. But then of course, the output of the thing, the 40 watts per channel, they use transistors. So it was the first hybrid that they came out with. And I thought, you know what? I better get out the manual and I better go through that thing, and I better try to find those parts now. I need at least one set of replacements, because if one of those ever goes out, say like 10, 20 years from now, I'm screwed. What are you going to do? So everybody needs to start thinking about that. These parts are getting scarce, and it's getting worse. Like I said, it's not as bad as it was 10 years ago, but now I'm already starting to see, it's getting to be a problem. So I suggest people get the parts. If you got some old stuff you plan on keeping going until you die, you better get the parts for it now. Get a set of replacements for everything you've got, because if you don't, you're going to regret it. You're going to wind up throwing stuff in the dump when you don't really want to. So that's all I got to say for now. And like I said, I'll do some more work on this thing next weekend. I got to clean this up here a little while. I don't have time to do more of this today. I guess I could mount the RCA jack and wire that coax up, but I think I'll just wait until next Friday night or next Saturday or something, next Saturday morning. So that's it for now. This is W5HRO, and I hope this has kind of been educational. 73s for now.